Okay. We're going to look at heating and AC test 14 today. We have 25 questions, and we're going to look at the alternative that best completes the statement or answers the question. Which of the following is the unit for electrical pressure?
Watt.
Electrical pressure.
Watt.
What?
I don't want to say ohms. That's resistance. What resistance do you say?
Remember Ohm's law?
Yeah.
How does say Ohm's law?
I equals.
Well, I mean, one blank pushes one blank through one blank. You remember, Quincy?
1 amp pushes 1 volt.
You forgot it, didn't you?
Yeah.
1 volt pushes 1 amp through 1 ohm. Okay, let's go back and ask this question again. Which of the following is the unit for electrical pressure? 1 volt pushes 1 amp through 1 ohm.
Volt.
Volts pushing. So volts is the pressure. The more pressure you got, the more. What do we do to make the spark plug, jump the spark plug out? We've got to take 12 volts and we've got to make it 100,000. Because the 100,000 volts will jump across that gap. Got me? Right. T if the statement's true, and F if the statement is false. Most automotive electrical circuits use AC current.
Only if they're a hybrid.
Well, the most is the key word here.
False.
Yeah, DC current has always got the same polarity. AC current's what's coming out of the wall. AC current is how you have brushless motors. You know, on a brushless motor, you're basically dialing your voltage in on the stator that's on the outside and the permanent magnet's on the inside. One of the, let's see, a fusible link is usually 4 wire sizes blank than the wire used in that particular circuit. This, fellas, is a fusible link. This fusible link has got hypoline insulation, which is super high temperature insulation, and this wire on the Ford vehicles, the wire is a silver color. It's got platinum in it or something. I don't know. But what long and the short of it is, this particular wire, I've got it stripped back, you know, so you can see the wire on the inside of it. It's going to be smaller than the circuit it's protecting. And the reason is because if you want the thing to burn into when you got an overload on the circuit, you want it to burn into where this hypoline insulation is. And if you look at one of these fusible links and you want to see if it's burned in two, all you got to do is try to stretch it. And if it stretches, it's burned in two on the inside, because it may not even breach this insulation. Sometimes it will, but it may not. But that's a fusible link right there. And that's going to be right there where the power is being fed out to whatever is being fed. Now, this is mostly on older vehicles, but you will still find a few of these on newer vehicles. That's a fusible link, all right? Had that in the drawer for a reason, huh? So basically, it's going to be smaller so that it will burn in two. And remember, it's got hypoline insulation. You can actually buy a fusible link wire that's got special hypoline insulation on it. I don't like it really, because I like for the wire to have that silver colored wire on the inside like they have on a Ford fusible link. Which of the following is considered I'll tell you something else too, fusible links are expensive. You know, that little fusible link there, a lot of times if you went to buy that fusible link, it'd be $12 or $15 sometimes. It's pretty high. Which of the following is considered an output device in an automatic temperature control system?
Both A and B.
Compressor clutch and the blower motor. Right? Which of the following is monitored by a sensor in the ATC system?
All of them.
Ambient temperature, sun load, and vehicle temperature. What's ambient temperature?
It's the temperature outside.
Yeah, that's what's out here in the air. In vehicle temperature is what you're feeling inside there. Sun load, if the sun is beating on the car, and you know, a lot of vehicles don't have a sun load sensor. How many times have you been riding along with somebody else in the car and the sun's beating on them and they're saying, I'm hot, and you're saying, well, I'm kind of chilly over here. I mean, you know, see the imbalance and that kind of thing. So it changes what the AC does with its compressor clutch. But typically you're going to see that on automatic temperature control vehicles, you know, that's what that is. Electrical mode doors in an automatic temperature control system usually have a feedback sensor string connected to them.
True.
I'm going to go with false.
That's actually true. I mean, that sounds like a feedback sensor string. That seems kind of silly, doesn't it?
Yeah.
But I don't know why they'd use those words. But that blend door actuator we put on that blend door actuator that we put on that 2006 model Chevrolet truck the other day, that was going click, 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 click under there. It actually, those are peculiar, those GM, because basically what they do is there's 5 volts go into that thing. And when you put that 5 volts to one of the wires, it drives the motor one way, and you put it to the other wire, it drives it the other way. And there is a way you can test those if you know what you're doing. That GMC over there set up that way. I need to show you all that. Which of the following test instruments can be used on any automotive electrical circuit?
I'm gonna go with the test light.
Well, what do you think?
Maybe test light.
Digital multimeter.
Well,
Now, I mean, I hammer on this all the time, but a digital multimeter, if you're measuring a load carrying circuit, is useless. It's absolutely useless. And a lot of the school, manufacturer schools will say, oh, you don't ever need to use a test light, because they're terrified that you're going to burn something up and they're going to pay for it under warranty. But I'm telling you, when I go to these electrical classes that I go to sometimes up in Kansas City at KC Vision, those instructors are real world guys. They fix cars every day. They're not people that, you know, teach for a living in a manufacturer school. And what they said was,
Everything's wiped down and put up. Bonnie says thank you.
yes, ma'am. Or yes, sir, excuse me. He said Bonnie, and I said, yes, ma'am. Anyway, this guy showed me a box that had 6 stoplight bulbs on it. And they were wired in parallel. And coming out of the box was 2 wires. Right? So basically what you're going to do, when you hook power and ground to that, all 6 of those stoplight bulbs are going to line up, light up. If you got a ground that you suspect may be causing you a problem in a load carrying circuit, basically what you're going to have to do there is you're going to let this thing go through. I mean, let that ground pull those bulbs. You got me? And if you don't need quite that much current, you can take a couple of the bulbs out. You got me? That makes sense? There's even a diagram in one of these books I brought back from the school that showed you how to build one. Now, the people, if you showed that box, if you took that box to a manufacturer school and said, this is what I use to marry load carrying circuits, the guy at the school would probably say, oh, throw that away. You'll burn something up with that. But I'm telling you, I've actually used a meter to troubleshoot circuits that were supposed to be load carrying circuits. Had the meter tell me I had the correct amount of voltage, went around and around and around, worked an hour, and found out that if I'd have used my test slide, I would have fixed the thing in 5 minutes. So I'm telling you, current dropping resistor, if there's no load on the circuit, you're going to see voltage. You got me? Let me ask you this. I've got, let's say on a Jeep, Cherokee, like a 2000 model, 2001, the last years they made them, and some of the others. They've got these little switches that are built in there for your air conditioner, for the low pressure switch and the high pressure switch. And there is 12 volts coming out to those high pressure switches. And whenever that switch closes, it shorts that 12 volts to ground. How is that possible without blowing a fuse? There's no current there. All there is voltage. You got me? And if I've got a current dropping resistor in my module that's letting voltage go out there, and it's actually measuring that line, and it has got in its logic algorithm, if this voltage drops below this, to 0, then I'm going to take this action. See what I'm saying? If the voltage drops to 0, I'm going to do this. I'm going to turn the compressor on. I'm going to turn it off. If it drops to 0 on the high pressure side, I'm going to basically do the turn the fan on and turn off the compressor or whatever. So that 12 volts is basically not going to burn a test light, is it? But you can measure it with a meter. That's when it's appropriate to use a meter. You got me? And it's also on 5 volt circuits, like on your sensors and all that kind of stuff. You use a meter on those. So I always have to hammer on that, because even Daniel, when he went over to the Nissan place, he was checking something with a test light. It was a load carrying circuit. And one of the other mechanics says, the guy at the school would tell you to throw that test light away. Well, the guy at the school is a buffoon. Excuse me? I mean, I've never burned anything up with a test light. I mean, you can if you're a dum-dum, but most of that stuff's tougher than that. See this here? Modern electronic circuits can be damaged by rough handling, excess heat, electrostatic discharge.
Any of these?
Any of them.
I've got, right over there somewhere, I've got a smart junction box that came off of an Explorer or something. And it's got words on the junction box that says if you drop it from more than 20 centimeters, scrap it. Now, that wouldn't be it there. It's basically like the fuse panel is what it amounts to, bigger than that. That came off of a Mercedes or a Crossfire. But anyway, long and short of it is you'll see that box. It's a pretty good sized box. It's looked like it's a fuse panel. It's up there somewhere. And that's a wiper governor for a Nissan. Anyway, long and short of it is you ain't going to find it. But it's got words on it that says if you drop it from more than 20 centimeters, scrap it. You've also got on these doggone air conditioner control heads, it'll say if you drop it, scrap it. In other words, if it gets away from you and it falls on the bench, it's junk. I mean, that's how those things are. Which of the following is true concerning ohmmeters? A, ohmmeters cannot be used to check continuity. B, ohmmeters can be used on live circuits. C, ohmmeters are self-powered. D, none of these are true.
None of these are true.
What? That's actually C, they are self-powered. They use their own little battery current. Here's another problem. You get an ohmmeter, I can get on one end of a battery cable and the other end of a battery cable with an ohmmeter, and I can find out that it has really perfect continuity. But you can take a piece of battery cable and grind every bit of it away except for one copper strand, and it's going to read perfect continuity. But is it going to carry a load? No, it's not. You got me? All right. So run into stuff like that before. And I had a guy farmer that called me out there one day to look at his tractor. I mean, gosh, I was probably 16 years old. And he says, I can't jump this thing off. I got a good battery in it. The starter's been replaced, and it won't do anything when I try to start it. And so I went over there and got to investigating that. And you know these battery cables that are molded, you know, the cable's molded onto the end of the cable. I mean, it's actually molded on there. I noticed when I was checking it with my test light that I had good power at the positive battery post, good power on the actual terminal that was clamped around the battery post, but when I poked into the wire, there was nothing there. Now, when you first poked into the wire with a test light, you'd see a light, but it was a little dimmer than the one that you saw touching the terminal. Okay, so when you try to start the engine, that would go away. But your power would stay at the battery terminal, and it would stay on the post, but it would go away in the wire. What's wrong?
Corroded on the inside?
Inside, where it's molded together, it looked perfect. But I took it and put it down on a piece of the tractor that was really hard metal and whacked it with a hammer a couple of times and squished it out so that it would bite into that copper and put it back on. He was running. But see, it had bumfuddled him because he put a starter on it, he put a battery on it, and he still couldn't figure out why it wouldn't start. You know, so that's, I mean, knowing, understanding that is really important. As a rule of thumb, for clutch coil resistance on an AC compressor should be what?
About 5 amps.
3 to 5 ohms, not amps. Resistance is not amps. All right, we're going to try to move a little faster on some of these other ones. Vehicle with an automatic temperature control system has heater and defroster operation, but the AC is not working properly. To diagnose this problem, you should do what?
Both A and B.
Neither A or B.
Check trouble codes. If it's automatic temperature control, you can usually do a dance on the buttons if you know which ones to press. You look it up in your book. Remember when Moody was working on that doggone Hyundai? You had to put this thing in it. This is a little thermistor that goes in the evaporator, and we were fooling around with it, checking this thing out. And what turned out was you could do the push on the two buttons on the temperature display, and it would throw you a code telling you what to look for. And it said this was bad. They put one in there, and they had good air, and they were so happy with that. They got the whole vehicle painted and everything else.
They took it and got it painted on them?
They got everything painted. They got the car painted. They've restored it because he got the air conditioner working. And they gave him a pretty generous tip too. An example of a short circuit is what? What is it?
A burned wire with bad insulation that touches ground.
All of them.
Look at this. I do not like that question and the way it's done, because one of those answers should be either A or B, because he was right when he said a burned wire with bad insulation that touches ground, that's a short, but a clutch coil with a resistance of 1/2 ohm is also a short. Okay, here's an air conditioner story for you. My buddy Donnie has this guy brings him a 2006 Impala. And the guy says, this thing blows the fuse when I turn on, for the compressor when I turn on the air conditioner. And Donnie says, okay, well, get it in here and we'll find out what's wrong with it. You may have a bad compressor clutch or something. So it didn't show up the Monday the guy said it was supposed to show up. So what the guy did is he got a piece of 12-2 Romex wire, stripped it, made it into a U, put it in there where the fuse went. He says, I'll fix this thing. It's not going to blow this fuse. So when the guy finally did come in, he had a lot more electrical problems, and it had melted the wire harness down, and it had wired a whole bunch of stuff together, just destroyed it. And so he says, well, gosh, what are we going to do to fix this? Now he says, well, we're going to have to price you out a wire harness. So he calls his Chevrolet, and they say, we don't make that wire harness anymore. Seriously? And he says, okay, so what do we do now? And he says, well, if you want to pay me by the hour, I can take this wire harness out of here, and I can strip it down, and I can fix it wire by wire. But I don't know how long it's going to take. And I get $65-$70 an hour, whatever he gets. So they said $800, $900 for me to do this, because I'm not going to do it for free. And the guy says, well, I'll just drive it like it is. Now, all he had to do was just bring it in when he was supposed to bring it in and let him repair what was wrong. But if you jumper a fuse out that's blowing, that's dumb. And that's an air conditioner story right there.
Reminds me of that guy did the same thing with a pistol shell. Put it in for a fuse.
Mm-hmm.
It heated up.
Yeah.
And went off.
Oh, you mean a 22
Yeah,
22 bullet? Yeah, yeah. And it heats up and goes, pow, That's funny.
Sorry, what was the
Yeah,
answer?
this outstanding performance. I mean, what? Oh, goodness gracious alive!
Do you want to say A or both A and B?
I want to just these knotheads on this one here are wanting B to be the answer, but why in the world? I don't know why they just put that first answer up there. The blower motor runs on high speed only. This indicates what?
The resistors are bad.
The resistor is bad because it bypasses that on high blow, right? Vehicle overheats because the cooling fan does not operate. This could be caused by what? Faulty fan relay, faulty cooling fan motor, bad fan motor ground connection. And what do? We take our test light, we hook it to hot, we touch it to the wire that's going out to the motor from the relay with the relay pulled out. We turn it through and see if the light ever goes off. You know you got a bad motor that way. Always remember that. A blower motor stopped working on all speeds. A technician tested the motor touching a jumper wire from the battery positive terminal to the motor power terminal, and the motor did run. Technician A says the motor should be checked using a fuse jumper lead to test for excessive current draw. Technician B says the resistor pack and or relay are likely to be defective.
Bravo.
What do you think, guys? You like that? Both technicians. It's going to be Charlie. Slap yourself and mark your answer wrong there, Joe. Okay, a blower motor is drawing more than the specified current. Technician A says the blower motor ground connection could be corroded. Is he right?
Yeah.
No. Is a corroded ground connection going to add resistance and cause it to pull less current, right? Typically. Technician B says the blower relay is shorted. Who's right about that?
Close.
Neither one of those guys is right. What's a shorted relay going to do? It's going to blow it on high blow all the time. A corroded ground connection is going to make the blower run slower than it's supposed to, but it's not going to, I mean, it can make it, it ain't going to make it draw more current, that's the point. Which of the following might be excessive current resistance? Might cause excessive current resistance. Short to ground, short motor windings, weak battery, corroded switch.
Shorted motor windings or shorted motor?
Now, wait a minute. Excessive circuit resistance, not excessive current draw.
Is that going to be a corroded switch?
Corroded switch, bingo. And most of the time, the switch is on the ground side of the blower motor, you guys. The switch in the blower resistor, in most cases, or a lot of cases, I'll say, I'm not gonna say most cases because I can't categorically say that, will be on the ground side. The power will be fed to the blower all the time, and the ground will be fed through the blower resistor from the switch. Let's see, the current flowing through a circuit is measured in what? Yeah, that was good. Amps, he got that one right. At amperes. The resistance to electrical flow through a component is measured in
Ohms.
ohms. If a conductor has infinite resistance, it is,
Grounded.
please, open. If it's got infinite resistance, it's like you've cut the wire, you guys. That's open, right? Don't embarrass me here, okay? Technician A says most late model control systems allow the system to communicate with diagnostic test equipment. What does that mean? Plug the scan tool in, right? Technician B says most late model control systems can run pre-programmed system diagnostics and generate trouble codes. Who's right about that? Both of those guys are right. Which type of circuit is shown in this particular little diagram right here?
Series circuit.
That's a series circuit, isn't it? Is he right about that, y'all? You got that? What type of circuit is shown in this one here?
Parallel circuit.
That's a parallel circuit, isn't it? Because everything's got its own little path by everything. The ground is shared by both, the power is shared by both. So when I say that, each one of them has its own path to ground and its own power feed. In this schematic, what approximate voltage will be displayed on the digital volt ohmmeter?
Not enough information.
Please, Joe.
We're not showing 12 volts going into the system, it's on the low.
About 3 volts, about 9 volts, battery voltage. Not enough information. What do you think?
3 volts. 3 or 9.
3 volts is good. You got the right answer on that one. Why? Where are you coming up with that?
Because it's going through 3 different resistors.
There you go. Very good. All right. In this diagram, you're going to see little schematics like this on your ASE test. Okay? And see that? That's your schematic. In this diagram, the blower motor is what? Is it not running because the relay is open? Is it running at low speed? Is it not running, or is there not enough information?
Running at low speed.
Okay. Now, what is the purpose of the relay? And when does the relay close?
Takes the load off the switch.
Come on, Bobby. What now?
The relay.
Look at the switch. Under what conditions does that blower relay work?
High.
High blow. How so? Is it because you read the words or you traced the schematic?
Trace the schematic.
Okay, show me.
Okay.
I mean, just give me. All right, so you got a ground or you got power. We got power or ground. What are you delivering? When you put it on high, what are you delivering to the high blower relay?
You're delivering power to it.
To what part of the relay?
I don't know that squiggly line's actual name.
That's the coil.
Coil.
And on the other side of the coil, you got a ground. So when you energize that, it's going to energize that coil, it's going to pull that relay closed, and then you're going to be delivering direct battery power from the B plus line to that motor. Everybody understand that? All right, that's good. Did everybody make 100 on the test?
Running at
Anybody got any question?
running at low speed.
Running at low speed is the right answer, that's right.